In the following sketch, AB is equal to AE. All right, AB is equal to AE. We are given this information that these lines are equal to each other. And then the first question, prove that BE is parallel CD. Guys, to prove that BE is parallel CD, when you're required to prove parallel lines, if the lines are parallel to each other, you have got three choices to choose from. All right, you have got the alternating angles, you have got the corresponding angles, and the co-interior angles. The first choice will be the alternate angles, right? That is the first choice. These are the alternating angles, and we know that the alternating angles, they form a Z, okay? They form a Z. And then the second choice that we're going to have, it is the corresponding angle, and they look like an F. All right, they form an F, which means this angle here, okay, which is the one that I'm going to show in red, this angle here must be equal to that angle there. Right? And how about in the alternating angles? We know that this angle must be equal to that angle. They are alternating angles. And then now let's go to the third choice. The third choice that we're going to have here is going to be the co-interior angles, okay? But mostly the co-interior angles is used whenever you're given the center. In this situation here, we're not given the center. In this case, we're not given the center, so it means it's already out, okay? It's out, but I'm just giving you three choices that you're going to use when proving if the lines are parallel to each other. So we know that with the co-interior angles, it means this angle plus this angle must sum up to 180 degrees. Okay, we know that they must sum up to 180 degrees. But now we want to answer this first question here. To answer this first question here, prove that BE is parallel CD. All right, we are going to determine which of the following choices here, which of the choices out of these three choices, which one will work. Obviously the alternating angles cannot work, so we are saying the alternating angles cannot work, which means this one is out. Okay, the first choice is out. And then how about the corresponding angles? Yes, it is going to work. We are going to form an F here. Look at this, we can form an F here. Okay, look at my green line here. We can form an F here, meaning that angle E1 will be equal to angle D1. Can you see that, guys? So an F can be formed, or you can say C1 can be equal to B1. That is also an F if you are looking at it from the left hand side. But now let's just look at the right hand side. All right, the corresponding angles is going to work. Right, that choice, the second choice, is going to work. How about the co-interior angles? I have said that the corresponding angles will only work if you are given the center. In most cases, right, if you're given the center, remember the center brings about the 90 degrees, the radius perpendicular the tangent. It also brings the theorem angles in the semicircle. So here it won't work, so it means it won't work. This won't work here. We are left with the second choice. The second choice must work. Let's look at that second choice. After drawing the situation here, you have to sketch the situation. Look at this. This is the situation. This forms an F there. Okay, it's an F. But now we have sketched the F. This is the situation. It looks like an F, right? Which angles do you think will be equal? Obviously, D1 must be equal to angle E1, okay? And that is our aim, guys. That's how you prove this. This is our aim. We want to prove that angle D1 is equal to angle E1. That is the aim, guys. That is the aim. So we will underline the aim. How did we get this aim? How did we get what we need to prove? By sketching the situation, drawing a picture, right? This is a picture of an F. After seeing the picture, now you can see that D1 must be equal to E1. So it means that is your aim. That's what we are required to prove. What you are required to prove, you are required to prove that D1 is equal to angle E1. Then you underline what you are required to prove. This is what you are required to prove. This is our RTP. That's our RTP. Required to prove. After underlining what you are required to prove, we are now going to prove these angles one by one. What do I mean by one by one? I mean we are going to look at D1. Our first focus here is going to be angle D1. Okay, our angle D1. Angle D1 is going to be our main focus. Is going to be our main focus. We're going to be focusing on angle D1. Okay, now we ask ourselves now, what is angle D1 equal to? What is angle D1 equal to? Angle D1 must be equal to what? We ask ourselves that, okay? We are focusing on angle D1 only. Angle D1 must be equal to, angle D1 must be equal to angle B1. Why are we saying it is equal to angle B1? Remember the theorem exterior angle of a cyclic quadrilateral. Look at this. This is a cyclic quadrilateral. BECD is a cyclic quadrilateral because it touches the circumference 4 times. 4 times. So it's a cyclic quadrilateral. So it means B1, this angle here, B1, must be equal to angle D1. Exterior angle of a cyclic quadrilateral. I'm going to show this in blue. Can you see this? This is our cyclic quadrilateral here that we're having. Okay. And we know that angle B1 will be equal to angle D1. They are equal. Okay. Because of the theorem that says exterior angle of a cyclic quadrilateral. So we know that angle B1 is equal to angle D1. So angle D1 here is actually equal to angle B1. And what is the reason there? That is the exterior angle of a cyclic quadrilateral. Exterior angle of a cyclic quadrilateral. So that is the reason, exterior angle of a cyclic quadrilateral. We are done with angle D1, okay? One of our aims. Now let's go to angle E1, okay? This is my angle E1. I want to prove that angle E1 is equal to which angle? It's equal to what? I'm done with angle D1. Now I move on to angle E1. Now angle E1, let's go to angle E1. Can you see that angle E1 must be equal to C1? Okay, angle E1 is also equal to angle C1, but remember angle E1 is the same as B1. Okay, it's the same thing. Since we are given that angle E1 is equal to angle B1, we are given from the top there. Remember, we're given that AB is equal to AE. So what is that? That is opposite angles equal sides, because triangle ABE is an isosceles triangle. Right, so we're going to say angle E1 here must be equal to angle B1. Must be equal to angle B1. Why are we saying that? Angles opposite equal sides. Angles opposite equal sides. That is the correct reason for an isosceles triangle. You cannot write isosceles triangle. You're gonna get it wrong. That reason is for grade 9s. Okay, so we are done with angle E1. Angle E1 is equal to angle B1. What is the reason? Angles opposite equal sides. Okay, that is the reason. Now we are going to conclude. Okay, we're going to conclude with what we have underlined. We're going to say therefore angle D1 is equal to angle E1. And what is the reason there? Both of them are equal to angle B1. Both equal to angle B1. Now we're going to conclude with the question itself. Remember, the question says prove that BE is parallel CD. So there you have to agree with the examiner. You have to say therefore yes, BE is indeed parallel to CD. But which of the reasons did we use here? Out of the 3 reasons on top, look at the 3 reasons on top. We have used the corresponding angles. That is the choice that we have taken, right? Because it forms an F. Remember, look at the green lines. Look at the green lines on your situation here. So indeed, BE is parallel CD. What will be the reason? The reason is converse of corresponding angles. You have to say converse because you are proving, guys. It shows that you are proving. So it's converse. Converse. That is your reason there. And that is your full answer. Okay, that is everything there. Now guys, let's go to question 2. Question 2 requires us to prove that BC is equal to ED. So we'll have to indicate in the diagram that BC is equal to ED. Just before proving, you have to indicate. All right, we have to indicate. So it means now we are going to be focusing on, remember BC is actually on the line AC. So it means they want us to prove that AC is equal to AD. All right, that's what they want us to prove there. So I'm going to use a red pen. So this here, they want us to prove that AC is actually equal to AD. That's what they want us to prove. Okay, that's what they want us to prove, that this line here, okay, is equal to AC is equal to AD. Okay, so for us to prove that, it means if they are equal, if AC is equal to AD, can you hear what I'm saying? We are saying if they are equal. Yeah, that if question is very important. That word if is very important because it will tell us, directly tell us, that if AC is equal to AD, then it means, oh, okay, this C1 here, this angle C1 must be equal to angle D. Okay, this is D1. So we're required to prove that C1, angle C1 is equal to angle D1. That is what we are required to prove. How did we see that this is what we are required to prove? How did we determine that? Through indicating, guys. You have to indicate which lines are they talking about. If they say BC equal to ED, it means you have to indicate there. Just like in the first question, BE parallel to CD, it means now you'll have to indicate the parallel lines there. In the first question, we had to also show. So now let's go to the second question. BC is equal to ED. We have indicated equal lines. We have put equal lines here, okay? So now if they are equal, so it means that angle C1 is equal to angle D1. That's what you are required to prove. Remember, what you are required to prove, you have to underline it, okay? You have to underline it. Now you ask yourself one by one, okay? Let's look at angle C1. Angle C1 is equal to what? Remember the process. One by one. Angle C1 must be equal to angle B1. Because remember, we've proved that CD is parallel BE. So this is corresponding angles. Because remember, we've proved that BE is parallel CD. So therefore, the corresponding angles can work here. That C1 is equal to angle B1. Remember, it forms an F. Look at that F there, okay? So angle C1 is equal to angle B1. That is corresponding angles. It's an F, guys, okay? It's an F. If you want to see that F, this is the F that we're talking about here. This F, okay? That is the F that we're talking about. Now, let's go to angle D1. Since we are done with C1, now let's focus on angle D1. We're done focusing on angle C1. Now, let's go to angle D1. Ask yourself now, angle D1 is equal to what? Angle D1 must be equal to angle B1, okay? Exterior angle of a cyclic quadrilateral. Or you can say angle D1 is equal to angle E1. That is also corresponding angles. But remember that also E1 is equal to angle B1. So that is the allowed route, the route that you can use, okay? Now, we have proved C1 and then we have proved D1, okay? Both of these angles, we have proved that they are equal to something, which means they are equal to angle B1. Both of them, they are equal to B1, okay? Now, let's conclude. So, we conclude there by what we've underlined. Remember, what you've underlined, you have to conclude with it. So, therefore, angle C1 is equal to angle D1, both equal to angle B1. That is the reason there. Now, let's go to the last conclusion. The last conclusion has to be the question itself. Remember, the question says, prove that BC is equal to ED. Okay, therefore you have to conclude BC. Indeed, BC is equal to ED. You can just say sides opposite equal angles, or you can say angles opposite equal sides. I don't think they penalize you. It's fine there, right? Now that's how we prove, ladies and gentlemen. And if you master this art of proving, then you'll be fine in the exam. You'll be able to answer questions. Okay, join me in the following lessons to learn more, and we're gonna be doing a lot of questions so that you may practice and understand better. So thank you for watching. God bless.